The expansion continues. In this video, we will be looking at roadbed installation and track installation for the return loop and the lower end of the staging yard. Then, as promised, and because you asked, I'm going to give you a guided tour of the Quebec and New England. The last complete video tour was over 6 years ago, so a lot has changed. As always, if Cork and track aren't your thing, you can skip ahead to the 18-minute mark of this video and watch the tour. In our last video, we installed a section of the plywood sub-roadbed. Now we're going to move on to Cork and track. And along the way, I'll point out some lessons learned and favorite tricks that I use. By far the biggest trick to use is not to buy roadbed from a roadbed manufacturer. You can get a much better deal, up to half the cost, by buying a roll of cork from a cork supplier. The only downside, if you can call it that, is that you have to cut it in strips yourself. To calculate how big a roll I needed, I took the number of flex track that I had ordered, 36-inch sections, multiplied that by 1.5 inches of width, and then divide by 144 square inches per foot, and that tells you how many square feet you need. At first I thought it was going to be really tedious to have to measure out 1.5 inches each time I wanted to cut, until I realized that my straight edge is actually exactly 1.5 inches wide, and so it was the perfect width to make the cuts. Cork sheets are available in a variety of thicknesses. I chose 3 millimeters because I wanted to have the ability to have thinner or thicker roadbed depending on where I was on the layout. In other words, I could double up 3 millimeter to make 6 millimeters for the main line. 3 millimeter could be used on secondary trackage, and no roadbed at all could be used for spurs that had sunken into the mud, basically. Some people choose not to use roadbed at all for the staging tracks, but I prefer it as it provides some sound deadening and it helps to even out any irregularities in the surface of the plywood. So here we see the first set of 1.5-inch wide strips of cork. Most of them are 4 feet long, a couple of shorter ones that I cut in half. Unfortunately, you can only use 1.5-inch wide strips for tangent or straight track because you can't easily bend it without it buckling. So for all other tracks, I need to use 3/4-inch strips, so it's twice as many cuts. So once again I thought, oh no, I'm going to have to measure out 3/4 of an inch over and over and over again. How am I going to do this? It didn't take too long to figure out the obvious solution. By not cutting all the way through on the first 3/4-inch strip and using my straight edge from the bottom of that strip to the top of the second strip, which would be 1.5 inches away, give me 2 3/4-inch strips. Then the process is just repeated, provided you always leave one 3/4-inch strip not yet removed from the roll. I quickly guesstimated that I need 2 dozen strips, and so here they are, ready to go. Before I did anything further, I redrew the track center lines directly onto the plywood because the tracing paper would just keep moving and shifting about. I then noticed that there was a certain unevenness where the sections of plywood met each other. Not a lot, but enough that it would cause a bump in the roadbed. So that had to be fixed before we did anything further. I briefly toyed with the idea of using small metal plates to raise the tops of the plywood to the same level, but quickly realized that wouldn't work where the middle of the joint was lower than the ends. So I opted for the more traditional splice plate or sandwich. One of the lessons learned from the earlier construction on the layout was that using the same screws everywhere can be problematic because if they're too long, they'll end up going through both pieces of plywood and sticking out as a safety hazard. So I tried to find some mid-length screws to hold these pieces together. In some cases that wasn't enough Due to variations in the thickness of the plywood, yes, all 5/8 inch plywood sheets are not the same. I had to add some shims. I know a lot of people use glue to secure their roadbed in place. I've always preferred to use small nails, in this case 1/2 inch flathead nails, because it provides the opportunity to adjust in place, remove, relay. It allows you to get a smoother curve, especially when you're transitioning to tangent track. Here's a closer look at how I build the roadbed for my turnouts. There's really only one cut required. If you do it right, the angled piece that you cut off flips over and fills the void next to it. I don't think there's much else that needs to be said for Cork roadbed. Just trust in your track center lines and put each 3/4 inch half of the roadbed along those lines, and it'll come out just fine. You'll notice that I didn't continue installing the Cork roadbed all the way around the first half of the helix. That's because it's a really convenient and comfortable place to cut the strips of cork. So I'm going to do a bit more cutting to build up an inventory before I finish that section. Because so much of this layout expansion is hidden from view in staging yards and return loops, I decided to go with Atlas Code 83 track. It's a little less expensive than microengineering, but I do have some microengineering on hand for the visible part of the layout that you'll hear about later on. The difference that microengineering FlexTrack provides is a slightly more realistic tie cross-section. The rails are also not as free moving, so it holds its shape better. I'm using the Walthers Code 83 rail joiners for the Atlas track, but I do have some microengineering joiners that I'll use on the microengineering track. Both the FlexTrack and the Walthers turnouts that I'm using have drilling locations or partially drilled holes for where the track nails go in, but you have to open them up with a pin from the underside. The trick is to use the right size pin so you don't break the ties. Or the pin for that matter. I eventually found a medium-sized pin that would work well. Here's a close-up view of the Goldilocks pin. Before we get started, we have to make room for the rail joiners, so the first tie at both ends of each piece of FlexTrack and all 3 ends of the turnouts need to be removed. This is okay because the second tie in each case is where the hole is located for the first track nail. What you're seeing here is the first track that I have laid in probably 20 years, and because it's been so long, I didn't do it correctly. So this is how not to install FlexTrack. I'll show you why. I installed this track kind of backwards. The free moving or free floating rail should run on the bottom so that when I curve it, it extends beyond the last tie. I did the opposite so that when I brought out my Dremel tool to cut off the end of the rail, I realized I'm also losing 3 tie lengths of track plus the hole that holds the nail in place. I then had to cut a 4th tie out to make room for the rail joiner, and I had to trim the rail joiner a bit because there wasn't any give in the tie on the bottom rail. In the end, I got it done, and it's a smooth joint, but it is less secure. As you can see from the previous clip, I didn't take my own advice and cut the last tie off both ends of the FlexTrack. Here's what the joint should look like when you do it correctly. Notice the long length of rail extending beyond the last tie, and cutting off the rail will not lose any ties. Note also the use of a clamp to both hold the rail in place so it doesn't fly off when it gets cut off, and it also acts as a heat sink so it doesn't melt the plastic ties adjacent. A nice straight joint is made before the loose track gets curved in place. I like to put a couple of nails in a little further away from the joint first, and then come back to the first nail to make sure the joint takes on the radius of the overall curve. I like to make sure I don't damage the rails when I'm hammering in the nails, so I use something with a smaller point to make the final few taps. I also like to add a little insurance at each one of these joints on the outside rail to give it a little bit more support. I put a little nail with a flat head that kind of goes in snug against the joiner to hold it in place like a spike. I decided on using Walther's No. 6 turnouts as the primary turnout for this expansion. It took a while to get there though. The standard turnout on the rest of the layout is the Atlas Custom Line Mark IV turnouts. I've generally been happy with them, with a couple of exceptions. The frog castings sit a little bit high, so every time a locomotive, especially a 6-axle truck, rides over them, they kind of bump up and ride over them. They don't derail, but it's a noticeable bumpy ride through the frog. Although I've never had to actually power any of my frogs, the connection point that's provided on the Atlas turnouts is right next to the frog. So if I did ever want to run a wire to it, it would be an obvious blob of solder right next to the frog, very distracting. The other thing I wasn't crazy about was the movable points are actually metal stampings as opposed to sections of rail. They also have that hinge point that's a potential source of electrical problems, although I really haven't had any in 30 years. The Walther's turnouts do away with all those issues, although they're not perfect, and we'll get to that in a minute. They also have the spring points that lock into place. The Atlas turnouts otherwise compare quite favorably to both the Micro-Engineering and Fast Tracks templates. Their guardrails are a little bit long, but so are the Walther's. One of the quirks of the Walther's turnout is they appear a little bit short when you compare the distance from the point of the frog to the point of switch. By far the biggest issue with the Walther's turnouts is that for some reason they've chosen to use much thinner tie cross sections than most other track manufacturers. This is easily manageable with either some cardboard or thin styrene, O10 styrene as a shim. In the end, while I really did like the realistic look of the Micro-Engineering turnouts, I had heard too many horror stories about their quality, the build quality, and how they fell apart upon installation. And I didn't want that, especially in hidden trackage. And they're separate frog castings. If you wanted to power them, you needed to solder a wire to the back side of the frog. So here we are installing our first couple of Walther's turnouts. Notice that there is about 1.5 inch gap between one turnout and the other, and that is because the track spacing in this staging yard is 2¼ inches, not 2 inches, and that is to provide a little bit of wiggle room for fingers to get in between the tracks to re-rail a car that might be derailed. And the first thing we need to do is make sure we set their locations correctly, because we have to drill a 1/2 inch hole where the turnout throw bar is going to be for the switch machines to be installed later. It is crucial that all of the turnouts in a yard ladder are in line. I double check with a metal straight edge and mark the locations where the turnout throw bars will be. A small section of flex track is cut with the Dremel tool to fit precisely between the two turnouts. Because the entire staging yard is essentially a large return loop, we need to put some electrical gaps in the trackage somewhere. I've decided to put them at the top and bottom of the helix, so there are only a minimum number of gaps required. This can be done by simply cutting the gaps into the track while watching not to cut through to the plastic ties to hold so the rails stay engaged, or using insulated rail joiners to hold the rail ends together. I thought I had a bunch of rail joiners to use, but they all appear to be too small. It's almost as if they're for N scale. I don't know where I got those. I did manage to find one that would fit, and you'll see that in the lower rail. I either have to run out and buy some more rail joiners or cut the gaps somewhere else. I had gotten this far in my track installation when I suddenly realized I had forgotten about the spring in the turnouts. Everything I had read online about these little springs was that you had to remove them if you planned to use switch machines. Before ripping up most of what I had installed, I decided to test to determine whether this was in fact true. As I had used Turtis switch machines on the rest of the layout, I had a spare one handy, and I had previously experimented with using a thicker gauge wire for the throw bar. Here you see on top the thinner gauge wire that comes with the switch machine and the thicker gauge wire that I had created as a test. In theory, the thicker wire should be able to apply more force to the throw bar to move against the force of the spring. Using the template provided with the switch machines and the wire dropped down through the hole at the center of the hole, the drill points are easily located beneath the layout. This is an ideal application for the use of Robertson screws. These are square head screws that fit nicely on the tip of the screwdriver and don't move as you're trying to install them, especially when you're upside down. So here we see the switch machine temporarily installed. It's not wired up. We're going to do this manually. Here goes. I think that means it works. Love to hear your thoughts on this. Not sure if it'll have a long-term effect on the switch machine motors. So this is where we are. The next step before we add the next half of the helix, we need to think about where we're locating our feeder wire drop points. So we're going to have to drill some holes and think about where the bus wires are going to go, what gauge to use. Didn't want to quite get into electrical end of things just now, but I think I'm going to have to. All that and more in our next video. But for now, let's have a look at that guided tour. We're going to start our tour by actually taking a walking tour through the layout. There's one 3-foot wide aisle that runs the length of the layout. To enter the layout room, the lower yard is on the left and the upper yard is on the right. This is a view you don't usually see, but you can see there is a valance hanging from the ceiling that mimics the fascia shape all along the layout, with the lights hidden behind it, of course. Here we see the main junction between the Q&NE and Conrail on the left, and the small interchange area directly in front, wrapped around the pond. Turning around now and walking back the way we came, we see the interchange support yard on the left, and directly ahead of us the diesel shop and our forest and bridge scene to the right. As we head back toward the entrance, you get to see the lovely mess underneath the layout. Please excuse this untidiness. And finally, we get a good view through the portal that we came in at the very beginning, and a quick peek at the extension that's currently under construction. Now we'll take a closer look at each area at a much more leisurely pace. Here we see the steel transloading facility at the end of the upper level. This is based on an actual real facility in Hamilton, Ontario. And next to it we have the scratch-built printing facility, newspaper printing facility, mostly just Walters brick sheet, laminated to a gator board superstructure. This has a unique feature of having loading or unloading doors on a curved spur. Across the street we have a plastics manufacturer taking in plastic pellets, some liquid chemicals, and shipping out plastic containers, sometimes in 86-foot boxcars, sometimes in double-door boxcars. And next to it we have a small specialty buildings product. It's actually the smallest industry on the layout. The upper industrial zone sits on top of the partially exposed helix that leads to the east staging yards. This is the double-track Conrail main line. It also allows for continuous running when I want to show off trains to visitors. Here's another view of the upper industrial zone, looking back toward it, and you see in the foreground the spur that runs up the grade. It's a 2% grade that runs up to the zone from the interchange yard below. It looks steeper than it is because at the same time it's rising at 2%, the double track main line is dropping at 2%. Here's another view looking back at the diverging grades of the three tracks. But the unique thing about this view is it's the only place on the layout where you actually have buildings or industries where you can see all four sides. You also get a look at the other end of the roadway that cuts across the entire peninsula. Here we have a view of the recently refurbished Q&NE diesel facilities, recently recoated, reshaped in company colors, and also added details of fuel stands, sanding tower, and finally added a fuel tank at the far end. I know it all looks too clean. We'll get around to that someday. There are a number of industries that are served from what we call the interchange support yard. It's really where inbound and outbound Q&NE trains are built or broken down. This is a view of the cereals plant that is made from Walters cornerstone kits, plus spare parts from the Walters Magic Pan Bakery and the cement plant. Immediately adjacent to the cereals plant is the only printed backdrop on the layout. It just seems to fit there. The next industry along is just a plain Jane warehouse that's accessed off a switchback from the cereals plant track that runs inside the building. It has 3 car spots. At the west end of the yard, we have an automobile parts stamping plant. It takes in coil steel and ships out automotive stampings, obviously. It holds 2 coil steel cars in the taller building and 5 60-foot box cars in the shorter but longer building. In the background here we see the now abandoned power plant and the new high tension power lines that were installed to reach the new substation that was built near the junction between the Q&NE and Conrail. This is a new installation completed last summer. At some point I will add some local power distribution pole lines from the substation to various buildings. This is one of my favorite scenes on the layout. We have a road crossing through the middle of the junction, complete with working gates. Next to it is the last industry we have that is served from the interchange support yard. It is a sandpaper manufacturing plant made up of 3 different kits. This one was neat because the old Red Wing milling kit was unwrapped, so you get 3 sides wrapped around the corner wall. Every layout needs a scenery only section where there's no buildings, there's no reason for the train to stop, just somewhere for the trains to pass through between cities, if you will. This is mine. Also the only place I could find that I could add some nice bridge scenes, do some rock carving, have lots of trees. And you can see it leading off into the tunnel on the right. That's the helix that leads to the west staging yard and also allows for continuous running. Tucked in the corner we have the shingles manufacturing plant with a couple of spur tracks for granulars and loading finished product. This is a kit bash between the Walters tire manufacturing plant and the George Roberts printing company. Immediately to the left of that we have what I'm calling a furniture factory. It's neat because it was built using 3 Walters background kits wrapped around an inside corner of the basement wall. You can't tell, but one of the walls behind is just a sheet of styrene because there wasn't enough material to do all the walls. It wasn't necessary either. The rest of this wall is just urban scenery. No need to have every building serviced by a railway siding. This gives you the impression that this area is part of a larger industrial zone. These buildings are a combination of Walters Cornerstone kits. It's the build your own system that they no longer sell. Plus at the far end, it's one of their kits that I think it's the hardware company that's fully unwrapped. So all 4 sides of the building are flat against the wall, which gives the impression of a very large industrial building. Now we're into the lower yard area, which supports 6 major companies that are located all around it. In the foreground here we have the gas supply company that takes in anhydrous ammonia and liquefied propane. In the background we have a very large grain mill. This was a neat experiment for me, and I wanted to have a very imposing structure. It's made from 6 Walters grain mill kits. It can handle 4 cars on the unloading track and another 6 cars in the overflow track. Next to it is a metal fabrication plant. This is made from 2 kits. The office building is the REA Express building, I think, office building, and the metal buildings are actually from the steel mill, the rolling mill kit. The overhead crane and gantry system, I think, was a 3rd separate kit. The next industry along is actually one of the largest, if not the largest, I think, on the layout. It is a paper plant. It has 4 tracks and takes in all kinds of products that you'd find in a paper making plant, and includes 2 outbound tracks on a slightly elevated grade. This industry was scratch built following actual plans. and photographs from a real facility in Thorold, Ontario. It's called Fraser Brothers, or it was called Fraser Brothers paper. It's now no longer, unfortunately. Rounding out the customer list on the Q&NE is this refrigerated warehouse and a bulk transfer facility next door to it. The refrigerated warehouse is incomplete. As you can see, it's got a bare roof. It needs refrigeration units on the roof. We'll get to that. The bulk transfer facility has 2 tracks, one for liquids and one for dry products. I thought it might be interesting to try and simulate a drone view of the layout. So here we are walking back the way we came. Here's the lower support yard and all the industries we talked about. It gives you a better view looking down rather than looking from the side. You get a better appreciation for the track arrangements and the space between buildings and track, etc. This shot here gives you an appreciation of how the tracks separate, implying some distance between the Q&NE main line and the Conrail main lines, and the tracks are cutting through the forest. You get quite a different view looking down from on top than you do from the side. Here we get a better view of the interchange track and how it is placed between the single track Q&NE mainline and the double track Conrail mainline, and the interlocking systems on either end of the interchange yard with all the various crossovers allow for the Conrail trains to set off cars and pick up cars through all these various crossovers. There's another example of a large bald roof that needs some detailing. This concludes your personal guided tour of the Quebec and New England Railroad. I hope you have enjoyed the tour, and we hope to see you again real soon. As always, thank you for watching. If you enjoy layout improvement videos, here are a few others that you may find interesting. If you're not already a subscriber, you can click on the logo on the top right-hand corner of your screen.